So our presentation today is all about tips to save time on and off of the game table. So we're going to have a jam-packed presentation full of different ideas for all different areas. So as we already heard, my name is Eden. I've been involved in FLL Challenge since 2007.
My name is Logan, and I've been involved since 2010.
And we are brother and sister. So we've been involved with the Waffles for a long time. If you knew us back then, we were very small versions of our current selves. So we've been doing it for a long time, and we've really enjoyed it. So we were part of the Waffles team, as mentioned earlier. We were both on the team for 5 years. So we both started when we were 8 and then went until we were 14. We were a very competitive team, not that we aren't anymore, but when we were on the team, it was a competitive team, and we usually advanced to the provincial level and to the World Festival twice when I was on the team. We've won several awards for robot design, for programming, for overall, performance or championships awards. So our experience has paid off, we think. So we just want to share what we learned from our time in First LEGO League Challenge, and hopefully that will be helpful to you guys. So the topics that we're going to be going over today are saving time in a bunch of different areas. So we're going to start with programming and debugging, and navigating the game table and a little bit of strategy there. How to be efficient while you're at the game table, and then some things that you can do in the off season to help you save time during the season. So the first thing we're going to talk about is what you should do before you run your robot. So it's always good practice to check over a few things before you run your robot, whether that's when you're editing your program or when you're practicing or when you're at a competition or otherwise competing. So we have a brief list of some of the main things that you want to check. So the first thing is robot battery level. This is a really big one. It happens all the time. There's been lots of times where we've made a lovely program and then it doesn't work the next day, and we find out that it was because our robot battery was almost dead when we were programming the whole time the day before. So the robot battery level will impact your robot's behavior, so make sure that it's charged before you begin. Always make sure that you have the right program. This also sounds really simple, but the number of times that we've renamed a program or accidentally select the wrong version or a different one, and then change all the stuff and it confused why it doesn't actually change anything in the program. It saves a lot of time just to make sure that you're always checking that before you go to run your program. Lighting conditions, if you're using light sensors, are also really important to check. If there are bright spots on your game table, or if it's a gloomy day, or if you only have artificial lights, that'll all have a different kind of impact on the values that your sensors are going to read. So try to keep this in mind and keep the lighting consistent as much as you can when you're programming your robot. And then the last thing you want to do is do a visual inspection of your robot. So you want to check over and just do a physical evaluation to make sure that everything is in place. So examples of this are the tire treads are on properly. They're not kind of riding off in some places, because that happens sometimes. Pegs are popped in properly. Everything's connected with the way it should be. No parts are missing, and all of your wires are properly clicked in as well. So just checking all those things. It's a really simple list, but if you make a habit of doing that before you work on your robot, it'll save you a lot of time in the long run. So the next area we're going to talk about is programming tips. So there are a lot of different things that you can do in your programming that will save you time down the road and actually when you're on the table as well. So the first thing is proper comments. And this really makes a world of a difference when you're editing your code. When you don't have any comments, it's very easy to accidentally change the wrong part of your code and then have a lot of confusion that's involved with that and have to redo work. And that's really frustrating. So make sure that you have comments throughout all of your programs. A common mistake that I see with commenting is that teams basically reiterate what the actual block already gives the information on. So we have an example over here on the side. of what a good example is and what a common mistake would be. So what you really want to do with these comments, our dog is walking in. What we really want to do with these comments is to help you understand what each part of the code is doing. So you want to reference what your robot is actually doing in the physical space that it's in, rather than what it's doing in terms of the code itself. So, relate it to landmarks or what you're doing for a mission, or what direction you're moving, that kind of thing, to help you understand really what's going on. So that'll help you a lot when you're going to edit your programs. Another tip that you can use is to add your previous values for whatever values you're using in your code, so that if you need to revert it back, or you can't remember what increment you changed it by, if you wanted to change something else by the same thing, you can include that in your comment as well, or you can just put a little note underneath. But just to keep track of that helps a lot to make your programming more efficient. We also do something that we call a start comment or a big comment. And basically, this is just a really big comment at the beginning of all of our programs that provides an overview of what that program does and the progress that has been made on that program. So this is an example that we have here with just the name of the actual program, who it was changed by, when it was changed, what it does, what it currently does, and what has been changed over time. So it really helps to have all this there so that you know that you have the right version and you know what you need to do when you open up the program to work on it. And if you have any questions about something that was changed, you know who changed it, so that you can have a conversation and work out any confusion that might be there. So the next thing is version control. So this is really important. You want to save multiple versions of your programs in case you need to revert back. So having a consistent naming convention to avoid any confusion or accidentally running the wrong program, like we were talking about earlier, really is an important thing to do. So here's a basic naming convention that you can use is your run name, and then you have V for version, and then 1 dash another number, or number dash number. So the first number just indicates a large change in the program, and then the second number is something smaller but still worth updating the actual program for, in case you want to revert or just to keep track of things. Don't use something that's really generic, or use what is already used in like the default thing, because it can cause issues and confusion later. Remember to name the programs within your project too. So at the top here, this is the project for EV3 programming, and down here is the actual programs within that project. So make sure you remember to name both, because if you just name this one, then this one will show up as like program 1 or something, and that can be confusing when you're going to run your robot as well. Also remember to save your program regularly. That's really important. It's a no-brainer, but it sometimes is easy to forget that, and you don't want to lose your progress. So make sure to save very frequently. And another thing that's going to be, I think, more important this year is syncing to multiple devices, especially if people are doing meetings on their own or not in the same space. It'll be really important to make sure that everyone has the most updated programs, so that they, to keep everyone connected. So it's important to do that so that everyone, has what they need. So there's many different ways that you can do this. I think they've talked about this in previous sessions, or on the session on Saturday, the weekend. But you can use a cloud service like Google Drive. We've used this in the past for our programs, and you can download the desktop version of that, so that it'll automatically sync files and download those, so that everyone always has the most updated version of your program. So that will help in the long run as well. A few more quick things about programming. So when you are programming, you can use time or degrees or rotations. So knowing when to use each of those is really important. and it can make your debugging of your programs easier and less time consuming. So on for time is really good for things that involve your robot pushing up against something. So it might not be able to reach, the exact number of degrees or rotations that you want. You'd have to get it really precise. So if you use time, then it'll just go and it won't be able to move maybe at the last, little bit of the time for the block, but it'll go to where it needs to go, and then it'll continue on with the program so that you won't have issues there or wonder why it's stuck. So like I said, moving into a mission model or a wall, or moving your arm down to activate something and it would get stuck on the model. Otherwise, we generally suggest that you use degrees for everything because it's more precise than rotations, and it will reach the intended distance more consistently than time because it's more precise, even if your battery is low. So using it over time, like using it instead of time, is a good idea because if your battery is low, then it'll move slower, but it'll only go for a certain amount of time, so it won't be the same depending on what your battery level is. So that's why we generally suggest using degrees. So faster when you're programming is not always better. Going fast can mean that your wheels can slip, or your robot will jerk between movements, and those actions create error, and then that makes your programs less consistent and less reliable. So to maximize speed while minimizing those issues, you can program your robot to gradually increase to your desired speed and then gradually slow down at the end of that motion, so that it doesn't have those issues in between. So there's a few solutions that we're going to talk about for this. The most basic one is to have multiple blocks. So have a block starting with a slow speed, then increase it, and then go back to the slow speed again. And make sure to use coasts between the blocks so that it doesn't have a chop between those and it just is a fluid motion. The next solution that we have is more smooth, but it's still pretty basic, and that's to use a loop to gradually increase the power level and decrease at the end, using smaller increments than just one big jump. And then the most advanced solution is using something that's called proportional integral derivative, or PID. And that sounds scary, but it's actually not that bad. It's pretty simple, and we're going to do a brief explanation of that. So basically, it's a controller that you can use to help your robot move more consistently and precisely, and it does this by keeping track of the error when it's moving and using keeping track of the error and the speed using a loop algorithm. So you can make this very complicated and make it more accurate and even better by adding those complications, but you can also just keep it very simple too. So Logan's going to talk a little bit more about this on the next slides.
Yeah, so PID, basically a really brief explanation of what it is. You take the desired distance or value, what you want to go, if you want turning or whatever your value is. You take that, bug, and then you calculate the optimal speed to reach that set point through 3 different variables. That is where PID comes from. That is the P, the I, and the D. After that, or during that stage, it also takes into account the error of how far along you are. If you're further than it expects or not as far as it expects, then it will calculate that and use that to make sure that it gets to the right distance. Then it outputs that, and then you activate that by just putting that into your motors, and that is the speed that you'll move. At the same time, it also detects the error. So if you're pushing your robot for some reason, this wouldn't happen, but if you hit something on the field or something, this might happen. It can detect whether or not it actually made that distance. And then the sensor inside of your motor, called the encoder, which measures the rotation.
Distance, yeah.
It sends that back to the original PID controller, which is when it uses that to calculate the error. And to the right, that's just a more detailed diagram of the PID controller.
Yeah, so this just loops over and over again, constantly checking the speed and checking how far you're off so that it can correct that. We have used this in our programming way back, and we use this resource here that we can have the link for you guys available as well if you wanted to look into this more and use that as a resource as well.
Yeah, and then just a couple of ways you can make it more complicated. You can use the gyro for turning with PID. You can also use the gyro for making sure you're straight with PID drive straights, and a few other sensors to make it more complicated. Okay, so this is just a little bit of how you tweak PID. The graph on the left here, you can see the blue line is where you want to go. Say it's wherever it is, 1 foot, 1 inch, whatever it can be. And then the three different other lines are showing how far your robot, say, moves that distance. So the black line, using PID, this one overshoots drastically the desired value, which means that it's going to try and correct that based on the error and go backwards, but because it's still going too fast, it's going to keep passing it and gradually get to its destination. It'll take a long time to get there. So then the green line is a better way of doing this. So it'll overshoot less and then come back, overshoot less again, and reach its destination faster. And then finally the red line, it gets them the same amount of time as the green line, but it never surpasses a specific point. So if that's a problem that you can't go past a specific angle or a specific distance, then you can use something a little bit more accurate, maybe a little bit slower as well. And then just an example here is a video of our FRC team. This is our autonomous rather. And you can see as it jitters back and forth, that's it trying to correct for it being off. That's the error.
And basically, you're just tweaking this to minimize the overshoot so that it will be smooth and have less jittering.
And that's the beginnings of it. So if you have really good PID, you wouldn't see that jitter. But because we're just in the beginnings of that, there's a little bit there.
Yeah, so that's a basic overview of PID. And let's playing this again.
Okay.
So the last couple tips we have for programming are to take advantage of our team's EV3 programming tutorials that we have on YouTube. So we have 33 really short videos on a range of topics on how to program basically everything that you're going to need for FLL challenge. And these can be watched at home or reviewed at home if you want to do that outside of your meetings to save that time having to teach that or repeat that or do that otherwise. They're very brief and they're super helpful. So you can take a look at those. Another thing is consider making a master program if you're a more advanced team. So this is basically just a program that contains each of your individual runs that you would run on the table as my blocks. So it's just condensing. There's a feature that you can use to condense all of an entire program into one block. So you just put that into the master program. So this just puts them chronologically so that you always have the right program, so that you're not during the match, you're not like trying to scroll through and find the right program or anything like that. And it automatically advances to the next one for you to be activating it by a button. So it takes that whole time of that out of the equation. So we have, like, once again, YouTube tutorials on these if you're interested in learning more about those.
All right, so some debugging tips. So there's a few different things that you can do from our experience that helps you make this process easier. So some things that you can do when you're changing your program is you want to make sure that you're changing one thing at a time. If you change more than one thing at a time, it's not clear what actually impacted the run. So if it works or if it doesn't work, if that changed, you don't know what part that you changed in the program made a difference. The other thing we suggest is testing your program more than once. If it fails once, that doesn't mean your program is broken or doesn't work anymore. You have to do it a few more times. Make sure it wasn't a fluke, that it just somehow messed it up if you lined it up wrong, something like that. And the last thing, these are a couple blocks that we use, the sound block and the wait block. So we use these to distinguish between different actions and identify parts of the program that are actually happening. So say you have some forks that are in your program, you don't know which way it's going, or you don't know why it's not getting to a specific spot, you can add pauses or sounds to indicate where in the program you are, which is really helpful sometimes for debugging.
And we'll have some video examples of that later to give you a bit of a better idea what we're talking about.
Okay, so a few more things you can do. So you can try slowing the problem, the part of the program that's not working down. This helps you see what's actually happening. It also means that if you're not using something like PID, you can tell if your robot is slipping a lot. See if it gets to the same spot, even if it's slower, because it should, assuming you're not using time blocks. So the next thing you can try is taking a video of your robot doing the program. This helps because you can rewatch what happened if something went wrong. And then another thing, just to make this even easier, is you can use slow motion videos, or you can do frame by frame to see exactly what happened if it's even still too fast with rewatching it. The last thing you can do, this is kind of a simple thing, but a lot of people don't do this, which is surprising, is to ask another team member or just somebody else around for their advice on a specific problem. This can oftentimes make the difference. It's super helpful. Oftentimes, a lot of people miss really obvious problems, and you just need somebody else to come look at it, especially when you've been doing it for a long time. It really helps to have another set of eyes.
So our next section is game table navigation tips. So first off, make sure that you are reading the game rules and checking the game updates regularly, because there's nothing worse than spending a lot of time on your robot or your programs just to find out that what you're doing isn't legal, and then having to redo it later. That's always really discouraging. So it's just always better to be very thorough and check those rules regularly. When you're navigating the table, you generally want to minimize the number of turns or stops or starts in your program, because each of these actions have a little bit of error associated with them, just because that's the way that it is. Nothing is ever exactly perfect. And when you have a lot of actions in sequence that have a little bit of error, it adds up to be a lot by the end of it. So ways to help with this is to group and complete missions by area. So stick within a zone per each of your runs that you're sending out, just to make sure that you're not moving unnecessarily, and making sure that each of those missions that you're completing are going to be done consistently and reliably. Try to do multiple things at the same time, or even with the same motion. If you can use a motor to do multiple things at the same time, that really helps to increase the reliability of completing those missions. You can also complete missions passively by either, driving by if you have like a hook on the side of your robot to pick up a loop, or to knock something, or whatever that may be, or to otherwise use a mechanism that doesn't require a motor. And that's something we talked about in our session last night. So if you didn't have the opportunity to see that, you can watch the recording of that later. Or you can just use a non-drive motor whenever possible. So basically what you're trying to do is to minimize the number of times that your robot is driving around on the table, so that you always know where you are, and you always have the best chance of completing your missions reliably. The last point that we have here is repeating a motion is much shorter than repeating a whole program. So if you have a mission that sometimes activates and sometimes it's a little bit off, it's better to add in a second motion to just drop that arm again, or bump that mission again, because that extra little bit of time can mean that you won't have to launch that mission again, and it'll save you a lot more time in the long run. So if there's missions that aren't necessarily working as well as you want them to, that's a good thing to consider. make sure that you're aligning your robot throughout the program. So if there's a lot of different things on the field that you can use as landmarks to minimize error in your programs by always being able to try and tell where you are on the field as much as possible. So there's a few different areas that we do, and then we do this a lot with our programs, which you'll see examples of later. So using the game table wall, so if you follow along a wall, you know that that's straight and you know where that is. So it's really helpful to line up on that, or to square up. If you back into it, then you know you're going perfectly perpendicular or close to perfectly perpendicular when you're driving away from that. You can do the same thing with some mission models to help you know where you are. So either, once again, by squaring up on those, or if you have an attachment that kind of goes around a model, then you know where you are at that point in the mission, and you know that from that point on, your run is more likely to be consistent because you kind of set a new baseline or realigned yourself. You can also use sensors to help navigate on the field and use landmarks. So you know them: ultrasonic, gyro, touch, light. Those are really helpful for being able to tell where you are in the field. And then a few tips specifically for light sensors that we've used. It's really helpful if you can have two light sensors in a row or in line, so that you can square up on a line. So if you see the line with one sensor and then you turn to see it with the other, then you're basically squaring up on that line, and that can really help when you don't have a physical thing that you can line up against. And then also, don't be limited by just lines. You can detect different colors on the mat, or different mission model colors, things like that, just to tell where you are on the field. So just think creatively about that and try to use these different ways to always keep realigning where you are throughout your program. So this is the first example here. It's a very quick video. This is a 6-second long mission from 2013 Nature's Fury, and it's really really quick, and it's a teaser video, so it's hard to see exactly what's going on, but we're gonna explain a little bit, and Logan's gonna help with that too.
Yep.
Where's my mouse? Here we go. So we're sticking to one specific zone here, and then it does all of those things all at once. So it's all in one motion going forward, and then completing all those tasks at once, so that we don't have to worry about maneuvering around the tree to do something else, or it's just a lot easier and more reliable to do that. So if you were at our session last night, we talked a little bit about one-way valves. So that's what we did with our loops here to pick up the cat and dog. And if you watch the flashlight here, we have a little bit of an arm that comes around to pick that up, and that's activated by an elastic, right?
Yes. It's activated by hitting the wall, actually, that activates the elastic. So no motors in this mission other than drive.
Right.
And that also, at the same time, same motion, like we were talking about earlier, we use the same activation system to pull off the tree branch. This year you had to take the broken tree branch off of the tree without hitting the power lines underneath it. So that was a good thing to do. It was really fast because we only had to follow the walls, just drive straight, drive back, and it was all grouped in the same area. So good mission.
So we talked a little bit more in depth about the different ways that we did that in our session yesterday. Just going to move a little bit more quickly through these because we're running a little bit shorter on time. But here's another example. This is from the Smart Move. So you can see that our robot is following the wall. We have little wheels on the side of our robot to help with that. And we lined up on the wall here. It didn't quite work. This was pretty early in the programming stage, but we lined up on this, and that helped to, realign that properly. We use this mission model here. We have a funnel that we talked about on the bottom of our robot to help guide us over this piece more reliably. And you can hear the beeps that we have in our program for debugging, because this is when we were trying to make sure that everything works. Once again, lining up on the wall and driving along the wall, and then beeping when we used our light sensors to detect this line here. So we're always trying to look for ways to tell where we are on the field. So in this video, we followed the wall, lined up on the wall, used a game piece to line up, and used light sensors to detect where we were as well. So our last example for navigation here is from body forward. So once again, we're following the wall, bumping into the back here, once again lining up. And then we line up again here just in case we accidentally mess something up there. And then most of our movements after that are more likely to be accurate because we've lined up again. We're using our light sensor to detect these lines here and our beeps during our debugging phase to make sure that we know exactly what's happening and when it happens so that we can effectively edit the program to make sure that it works the way that we want it to.
Okay, so being efficient at the table. So there's a few things you can do to make sure that you're really fast and efficient at the table. First thing is you can rehearse attaching your attachments and tag teaming on and off the table if you do that. This is important to do, especially because at the competition you want to be. These are generally where most teams spend the most time and waste the most time. So you can do this by either running full practice matches as if it was real. We can also just do this just by taking off and putting on attachments
and lining up your
robot,
and then switching. So not actually running your programs, but just practicing those transitions to make sure that you have them really down.
Yeah. The next thing you can do, you can choose a starting position for your robot that's easy to set up. So you want to avoid point and shoot missions because you don't want to have to be spending that time to have to eyeball and line it up, make sure it's correct. It has to be somewhat accurate. And there's a few different ways you can do this. So you can start on a wall. So we used to have 2 walls. Since last year, we only have 1 wall to line up on. So it's recommended that you have at least 1 flat face of your robot on that wall to make sure that you're going to be lined up correctly. If you're not doing this, if you can't do that, if you have to start an angle for some reason, you can also use things like a jig to space yourself off and make sure you're lined up that way. And then there's a few examples that we're going to show you in the next slide. Okay, so this is an example from body forward. We had a attachment on the back of us. We weren't able to line up properly on the back wall here. So we had a jig that fit inside of it and was lined up previously before this mission kind of came back. I messed it up there, but normally that wouldn't happen.
Limited footage available for this, but this generally makes it a lot faster to actually line up in your base.
Yeah. And then the next example, this is us lining up in 2. So this is lining up in the corner for our first mission. I think this is the first mission.
Mm-hmm. So we use both walls to line up there, which isn't possible with the mat this year, but just always taking advantage of the physical aspects of the field so that you can line them up reliably, because you don't have to think about which logos to line it up with or measure a distance. You just put it against the wall and that's it.
And just go. It's going to be much faster than other methods.
With this mission, another thing is this was a little bit more intensive to set up. So we started with that mission because that part wouldn't have been included. The setup for that mission is not included during the 2.5 minutes. So if you have one mission that takes a little bit longer to set up, you can start with that mission if it's suitable to do that to save time during the match as well.
So just being active in the off season, a few things you can do. Oops.
You can accidentally skip the slide.
So there's a few things you can do. You can do some preliminary research for your research topic. Oftentimes they'll give you the theme of the topic before the season starts. If you know you're talking about hydrodynamics, you're probably going to have to do something with water. You can talk to your local, sewage I don't know what it's called, sewage something, or
The example we have here was for trash trek.
Yep.
And we set up a field trip to go to the local waste management facility before kickoff started, just so that we could kind of wrap our heads around what we need to be doing.
And then some other things you can do is that you don't have to do, not all parts of the FLL challenge are in season specific. So you can work on things like refining specific mechanisms like one-way valves, but you can also do something more complicated, like we do our entire robot chassis or base in the off season, because we use something called the skirt, which we talked about in our last video, which is just where we attach all of our attachments on a base that's the same. So it's really easy to make that kind of thing to save time. That way, you can also improve your programming through making sure you can program a master program, PID, etc., to also save you time, not have to work that out in the actual season. And then the last thing you can do is you can watch videos on how to improve. This could be programming, building, whatever you need, whatever you're interested in. Watch them in the off season so that you don't have to take that time to actually learn it in the actual season.
And it's just interest based, and you have as much time as you want, and lots of teams to have inspiration from, because there's lots of teams that do things really differently from the way that we've talked about it in this presentation and our last presentation. And it's great to look at a bunch of different sources to learn as much as you can and apply that during the season. So that's the end of our presentation. So we hope that this was helpful for you guys, and if you have any questions, we can take them now.
That was a great presentation, Eden and Logan. And I loved especially the little video of some of the throwback seasons. I was so excited when the Nature's Fury video came up, because that was my first year. But we are running really short on time. It looks like we have one question, and maybe we could answer it quickly. And then I'd also invite you, maybe if you have an email that people could use if they have any burning questions later, they might be able to contact you.
Yes, we can send that. Do you want that in the chat maybe?
That would be perfect. Thanks so much.
Okay, perfect.
You can ask the question in the meantime.
Yeah, I'll just stop sharing to type that in.
We have two questions. One is from Chris. He asked, what do you do to save time from year to year?
So the main thing is doing the off-season stuff that we talked about in the last bit there. But also we have to reflect on what our improvements were from the last few years to make sure that we don't have to relearn lessons that we don't have to. Make sure you learn from your mistakes and keep doing that.
And this next question kind of goes off of that. Annie asked, is it recommended to reuse robot designs?
So this is a little bit tricky because we somewhat reuse our robot design. There's a lot of aspects of a robot that are the same, but we always look at a robot and see, what can we improve on it? Every year we've gotten a pretty small robot. We like small robots. We keep trying to make it even smaller, and our goal every year is to make it one beam's width smaller on any direction. So I mean, our last video, we had our most recent robot that we made, which was I think our smallest yet. So you can reuse robots. It's not impossible, and it definitely could work. But we like to improve it. We've never found a year that we haven't wanted to improve our robots. We've always remade it.
Absolutely. I think that's a really great attitude to have, to always look for improvement. And I think that's also a really good place to end off this segment. So thank you two so much for a really informative presentation. But there's a lot to take in there. And thanks to the rest of you also for staying focused and being an active audience.